Hi guys, welcome to Cafe.io. Cafe.io में आपका स्वागत है. In this video, we are going to be talking about large language models and taking a deep dive and understanding how they are priced, what this token means, and how do they go together. So, when we talk about large language models, and the first name that comes up in our mind is OpenAI. So, we'll take that as an example and move along. Most models are priced with similar concepts in mind. The actual amount might vary. So what I'm going to do today is take a look at how OpenAI models are priced when you're making an API calls, how different models vary, how their pricing varies specific to different kind of use cases. Then we'll get into understanding of tokens and what they are and how to actually count tokens. And what's the algorithm behind gaining an understanding of token, and finally look at a library which can help you gain a good understanding of tokens. So what I have over here is we are just on the pricing page of OpenAI, and we'll just move forward. So when you take a look at it, and we specifically try to read this, what language models are. Multiple models, each with different capabilities and price points. Prices are per 1,000 token. That's the first important thing to understand. We have prices specific to per 1,000 tokens. So that's the quanta in which we need to take the multiplication factor. So ideally it says that we can take tokens as pieces of word, where 1,000 tokens is about 750 words, and this whole paragraph that we have just read is close to 35 tokens. However, what really happens is people want to understand tokens a little more deeply and see how this influences their pricing and their calls, and when they design systems they want to be cognitive of that. So let's go to an understanding of it as how they are priced and move forward. So GPT-4 Turbo, which came out like a week or so about, is probably the first one that you'll see. It has the largest context size as far as I am aware of, which is 128K. And then you have two different prices. So one is the GPT-4 1106 preview and the other is Vision preview. And vision you have a pixel calculator, so you can probably have a small image which is 150 by 150, which is really small image. It's not a huge image. You can further make it low resolution, and the price would decrease, but this is the price that they are quoting. And the input and output are priced differently, so that's a very important parameter to understand. Let's probably take a second to understand what an input and output is. So when a user puts an input in ChatGPT, that's a user input. If OpenAI is consuming it, then that is pretty much directly what you can infer as tokens. However, when you're working with your enterprise applications, what you are doing is some sort of a RAG architecture. So that might not be the true count of the token which the user has inputted or given. So you take your context information and you mishmash by doing prompt engineering and all that. So you optimize the question or the prompt which you send to LLM. So that final prompt is where you should be looking at token and not the number of tokens in the user query. They might be different. Finally, output is the one which you get as a response. So these are priced differently. All right, let's go back. GPT-4 is priced differently. I think Turbo is cheaper compared to GPT-4, and I don't know what specific differences they have. Maybe the problem solving ability or the accuracy is better, but ideally they say that GPT-4 Turbo is more powerful than GPT-4. I don't know why that is. Then as you go further down, the cost reduces, like 3.5 Turbo will be there different. And there are different assistant APIs that OpenAI has built up. Now these could be, something like a retrieval API or a code interpreter API, which was free till a certain point, but now they have. So these APIs are different for different use cases. A code interpreter is, as it says, you are sending it bits of code. So instead of using some tokens, it's probably trying to use per session or something like that. So that's a different pricing model. If you're going by fine tuning model, again, there's an additional parameter which is training. So during training, the number of tokens you give, that essentially goes or is also counted towards the price. So you have an additional parameter when you talk of fine tuning, which is training, input users, and output. And here are the prices. Again, the prices are not, the specifics are not important. It could differ depending on what model you're using. If you're using an enterprise version of OpenAI from Microsoft, you would be different. If you're using Anthropic API deployed on Amazon Bedrock or something like that, you would be having different. If you're using Palm by Google, it would be different. But the concepts are largely the same. And then when you do embedding models like clustering, topic modeling, I would say good old NLP days, you have some base models like DaVinci, Ada, Babbage, and these are really cheap models. Most of the time, I don't know if people are using them, and highly likely that these would get shelved out pretty soon. When you go to image models, the pricing are different. Obviously, the quality is what drives the price. So probably we can see that an HD versus a standard is double the difference. This is $0.04, this is $0.08, so that's different. And as you increase the image size, it's expected that the price would also increase. And I think it's increasing in the multiplication of 0.04. So standard is then image. So basically standard of a higher resolution is same as HD, and HD higher resolution is probably the best. I don't think they have images before bigger than this. So that's the point. And then you have other audio models, which is again based on per time unit or number of characters processed. Note that this is characters and not tokens. So characters are different, tokens are different. And older models and stuff like that, not really important to go about. So now that's how the pricing structure looks. Let's go and understand what are tokens and how to count them. There's a very good, general terminology or algo that you can think about. One token is almost equal to 4 characters in English or 3/4 of a word, and 100 tokens is 75 words. That's how usually it goes. And that translates to, 1500. That's just multiplication. So you have certain examples, and this is from help.openai. So it was updated over a week, so pretty recent. So there are token limits set. There's token pricing different, which we have talked about, and then this website will give you can put some sample text and it will give you some tokens and all of that. It will give you information about the tokens. You can use this playground to understand and explore your use case and see how it varies and stuff like that. Pretty useful if you ask me. Finally, moving on, somebody in the developer forum in community of OpenAI, what they have done is they've written out a function, and it's a pretty straightforward function. It's just a simple Python code where they have covered all the cases, and they have just written a function. So if you want to calculate the number of tokens, you can use this. This is one simple way, but I would not suggest you do this because of performance impacts. If you are counting every time whatever text you are feeding to the model, that's just a toll. It's probably not a lot of toll, but it could come up if you are if there's some kind of significant I would say size of the number of tokens or number of characters. And this is a really fast tokenizer for using with OpenAI model, and you can pretty much it's really fast. I think the speed of comparison, the number of threads, it's doing good, and performance is measured on 1 GB of text using a GPT-2 tokenizer. It has certain specifics of tokenizers, let's just say certain algorithms of tokenizers, and you can use this to get the number of tokens that you have. This would give you a very straightforward output in terms of the number of tokens you have, and that would be a good way to calculate it. Ideally, when you are working with large language models, it would be a good idea to balance out this parameter, which is number of tokens. If you're specifically working with OpenAI, it's additionally a good idea to round it and take it as close to 1000 as you want, because that's the unit they are going to charge with. Something which I have not yet understood is, is the 1000 tokens calculated in a single call, or, subsequent number of calls, or the sessions are also factored in. I have tried to look for this answer, but I get mixed answers. So it's best to try to, dig a little deeper into how you're calling and how you are how many number of tokens you're sending. So that's something I want to leave with. All right, that's it. A pretty short video about this. Thank you guys for watching. Subscribe if you have already not. Bye bye.